The purpose of this video is to introduce you to the concept of logarithms, which we're going to be using a lot in this chapter and actually have a lot of real-life applications. So before we can talk about what logarithms are, we need to remind you of the old exponent rules that we know. Now, we should know all 5 of these from Algebra 1 and from when we talked about them earlier this year, but just in case they're a little fuzzy for you, I might suggest that you write them down in your notes. If you do that, pause the video now, and I'll be right here. Okay, so a logarithm is basically an exponent to which a base must be raised to yield a number. So if I were to say, I want to raise 2 to some power, and I want to get 8, and I asked what that power would be, you would of course say 3, because 2 to the third power is 8. Now, a logarithm is basically asking the same thing. Now, when you see a logarithm for the first time, it looks a little strange. You know you're working with a logarithm because you see the word log. There'll be a subscript number next to the log about 85% of the time, and when there's not, we'll talk about what's there. And the word log may sometimes not be there, but we'll talk about what would be there if it's not there. And then on the same level as the log, you might see a number. Now, there's 2 things I want you to know about these logarithms. First of all, how to pronounce them correctly. So if I were reading this out loud, I would read this as log base 2 of 8. Now, the other thing I want you to understand is what this log actually is asking. And so log base 2 of 8 means to what power must I raise 2 to get 8? So what power do you raise 2 to get 8? Obviously the power of 3. So log base 2 of 8 would equal 3. So do you see that this statement, which is asking what exponent you'd have to raise 2 to get 8, and this, which is asking the exact same thing, are really synonymous. So I'm going to go to the next screen. I'm going to talk about a few of these logs that you can do in your head. So log base 3 of 9 says, to what power must I raise 3 in order to get 9? That power, of course, is 2. And the reason because is 3 squared equals 9. Log base 5 of 5 says, what power do I have to raise 5 to in order to get 5? That power, of course, is the first, because 5 to the first is 5. Log base 4 of 1, that one requires a little more thought. But if you think about one of the exponent rules we had on the first page, anything to the 0 power is 1. Log base 4 of 1 is 0, because, I'm going to just do the, that's not good. I'm just going to use the shorthand for because now. 4 to the 0 is 1. Log base 3 of 1/3. So let's see. I have a 1 on top of a fraction with something underneath. So that usually, if I'm thinking of exponents, indicates a negative exponent. If I raised 3 to the negative first, that would be the same thing as 1 over 3 to the first. So log base 3 of 1/3 is negative 1, because 3 to the negative first is 1/3. Now, the statements on the left in this column and the statements on the right in this column are synonymous. Log base 3 of 9 equals 2 means 3 to the second is 9. Those two things are actually the same thing. They're just written in different form. Now, if you remember when we were talking about lines, we had 3 different forms of a line: standard, point slope, and slope intercept. And you could draw a line and write that equation in any of the 3 forms, but they all represented the same line. Likewise, with parabolas, we had standard form and vertex form, but they would represent the same parabola. These basically are 2 different forms of representing the same information. The left-hand side is called the logarithmic form. And the right-hand side is called the exponential form. So if I had an equation that was in this logarithmic form, but I generalized it, in other words, replaced it with letters, log base b for base of x, some number x, is y, and I wanted to write it in that synonymous exponential form, look at the pattern that I have up here. The base of these exponents, by the way, that's what that little number down below is called. The subscript is called the base, log base 3, right? That base in each of those logarithms became the base in the exponential. So my base here, which is b, would become the base of an exponential. So if I look now at the number on the other side of the log, well, the log is an exponent, right? So this is the exponent I would have to raise 3 2 to get 9, or raise 5 2 to get 5, or raise 4 2 to get 1, or raise 3 2 to get 1/3. So that part, the part on the other side of the equation, is going to be the exponent on that base. And then the other number, this little thing right here, by the way, that has a name. It's called the argument. That always ended up on the other side of the equation. And that's how it's going to work with logarithmic form. B to the y equals x. So that thing would end up over here. So last little bit. If I want to rewrite something that was in logarithmic form, into exponential form, it would be the base raised to the number on the other side, because a log is an exponent, equals the number that's inside the log, which is the argument. And if I wanted to rewrite something that was in exponential form, into logarithmic form, I'd have the word log. The base would be the base of the log. The exponent is what the log would equal. And this is what would be the argument. All right? So we're going to have some practice time in class for this, and you can ask me more questions then.